Hello everyone, welcome back. So our first group problem for dependent motion analysis. Now last time I told you, well, we only have one rope, so we only have one total length equation. Guess what? Two ropes! So in the figure on the left, the cord at A, right here, is pulled down with a speed of 2 meters per second. We want to find the speed of block B. So, what's your plan? Well, your plan is, well, there's two cords involved, so there's two position equations. And you're going to have to write these two equations out, combine them in some way, and then take the derivatives. So, with that in mind, grab a friend, grab a parent, grab a sibling, a spouse, grab your traveling gnome like me, and try out the problem. See how you do. And come back and tell me how you did. But just make sure you're alone, because you'll be talking to a computer and this is just a video. I can't actually hear it. But do what you want. Okay. Then mine, 3, 2, 1, and you paused. You're back. You rocked this example. The traveling gnome was surprisingly helpful. You were like, wow, he's got some good insights. And let's see how it goes. So, like I said, we have to write those two position equations. But before that we can do that, we're going to have to define our position coordinates. We have 3 different pulleys. And 3 different points that are moving. So pulley C moves, pulley B moves, and the end of the rope A moves. Now we're going to set a datum, and it should go through something that's not going to move, and the only pulley that does move is D, and so that's a good place to put our datum. And all of our links are going to go downward from that. Now we can, if you wanted to, define SB all the way down to point B, but this length doesn't change. And so this point and this point would have been connected. Also, since you see how we drew our arrows, all of our datums show down to be the positive directions. If we get a negative velocity or something, it means it's moving up. Okay, now we're going to have to write those position and length equations for each chord. We've got 2 chords, one that goes all the way from A over D, under C, and then up to the ceiling. And we have one from right here, which goes from pulley B up to pulley C and then all the way up to the ceiling. We ignore all the little pieces that are underneath or on top of pulleys because those don't change. If we look around, are there any other links that don't change? And the answer is, it does not look like there are. Yeah, it does not look like there are. So let's go through chord 1, which is this one right here. This one makes a whole lot of sense. SA is this one right here. And then we have this length SC, this center of this pulley, and there's 2 of those. And we're ignoring this section at the top. The chord 2, not quite as straightforward. You see SB, that's pretty simple. It's this strand right here. It's this strand right here which might confuse you. But what you can see is that that is simply the difference between SB and SC. We're assuming that, this chord sort of goes all the way to the center of pulleys. That's one assumption you need to make. So that's both of those. We have those both connected. Now, since the length of both of those chords is going to be constant, well, obviously, if we add them together, the length of both chords added together will be constant. And if we wanted to make things a bit simpler on ourselves, we can get rid of SC simply by adding our second equation twice. We can add as many times as we want, as long as we're consistent. And so what we get is SA plus 4SB is equal to L1 plus 2L2. We did that all to get rid of SC. We didn't want SC. You could have also solved for SC since you don't need to know that, and then plug and chug into the equations. There's other ways you could have done it too. Now we differentiate these, and obviously our total lengths are all going to go, are constant, and so their derivatives will be 0. And so we get 4 VB is going to be equal to VA. So VB is 1/4 of VA. And also they're in opposite directions. So as VB moves up, VA moves down. And you can see that. It makes a lot of sense for this one. It won't always necessarily make sense. So make sure that you are practicing and being consistent with your datums, so we don't have any issues in the future where you're like, oh, wait, I thought it went that direction. No, it actually went to the right, not the left. So make sure that you're actually practicing this now, being consistent and following the steps. Well, that's it for this one. Yep, we're going on to another group problem solving next. So thank you for listening, and I'll see you all next time. Bye-bye.